In this video, we will multiply rational expressions, and I'm going to start with an expression that is only numerical values just to see the pattern so we can then reproduce that with an expression with variables. So if I give you an expression that is 5 over 6 times 9 over 20. So you can multiply across and then reduce, which is what some people choose to do, and that's perfectly acceptable. But in this situation, I'm going to steer us in a different direction. What I would like to do is find all of the factors, and I'm going to go with, let's say, prime factors for each numerator and denominator. So 5 is prime, but 6 is 2 times 3. Those are the prime factors of 6. And then we have 9, which is 3 times 3, and 20, which is 2 times 2 times 5. And our goal here then is to cancel out or reduce by any common factors that we see in the numerator and denominator. So it doesn't matter where it's located in the numerator and denominator. And the reason we can cancel these out is because when I look at this and I see 3 over 3, this really is 3 over 3, which is 1. Okay, and then I see a 5 and a 5, so we can cancel those out. And anything that's left then becomes our product. So we have 3 in my numerator and 2 times 2 times 2 in my denominator, which then becomes 3 over 8. And so that is my reduced product. So let's redo this process except with variable expressions. For these problems, just like with the numerical values, we now need to factor. And with number 1, the first problem, the first numerator, we have 3x plus 6. And for this problem, I'm going to find, or for this expression, I'm going to find the GCF. So this will be 3 times the quantity, x plus 2. In the denominator, there really isn't anything to factor. However, if you'd like to, you could write the 5 and then break down the x squared into x times x. You can do that if you'd like to. In the numerator, x is what it is. There are no factors for x. In the denominator, x squared minus 4 has factors of x minus 2 and x plus 2. So now I look for common factors in my numerator and denominator. I first see a common factor of x minus plus 2 rather, and I see that I have one x in common here, and what's left then becomes my product. In the numerator we have 3, and in the denominator we have 5x times x minus 2. From here we can go ahead and simplify anything if we choose to, and again, you really want to understand the directions on how someone is wanting your answer to be the form that they want their answer in. This is a correct answer so far, but we could continue to take it a step further by distributing 5x, which would then give us 5x squared minus 10x. So that could be another potential answer. With number 2, you see that I have quadratic trinomials for each numerator and denominator, so factoring this will be a little bit more labor intensive, but we can still do it. With each of these, we will get binomials for my factors. So we have x and x. We know it's 5 and 2, and this must be a negative 5 and a positive 2. We know that this must be 7 and 5, and this must be a positive 7, and this must be a negative 5. Go on to the second part of the expression rather. Again, I have binomials, numerator and denominator. We know this is x and x. It's going to be 7 and 3, and that'll be a positive 7 and negative 3. Finally, x and x, we have 7 and 2, and they both are positive. All right, so from here, let's go ahead and cancel out any common factors. I see an x plus 2 in both my numerator and denominator. I see an x plus 7 in my numerator and denominator. And I see an x minus 5 in my numerator and denominator. So my final answer is in the numerator x minus 3 and in the denominator x plus 7.
Go Colts!